Hi guys, this is Reena B. George from RVG Maths and Talents. Welcome all of you. We are studying class 10 CBSE Mathematics. Let us start the next class, that is Polynomials Part 2. Already we have seen what is polynomial and types of polynomials, degree of a polynomial, and zeros of a polynomial in part 1 class. Okay. Here we are studying geometric meaning of the zeros of a polynomial. Let us just revise what is zeros of a polynomial. See, a real number k is said to be a zero of a polynomial p of x if p of k equal to 0. See, let us consider one quadratic polynomial p of x equal to x square minus 3x minus 4. And we have seen that this p of minus 1 equal to 0 and p of 4 equal to 0 in part 1 class. That means this negative 1 and 4 are called the zeros of this quadratic polynomial. Now let us start with a linear polynomial. That means the polynomial's degree is 1, then it is a linear polynomial. So consider this linear polynomial 2x plus 3. Okay. So here we are considering the graph of y equal to 2x plus 3. Let us draw its graph. Okay. Before that, let us find the zeros of this polynomial. Say p of x equal to 2x plus 3. We want to find out the zero of this polynomial. So for that, let us suppose that k is the zero of this polynomial. Then p of k will be equal to 0. What is p of k here? You substitute the value x equal to k in this polynomial. So 2k plus 3 equal to 0. Okay. That means 2k equal to minus 3. You are taking this 3 to this side. Then it becomes minus 3. Okay. Then you take this 2 to this side, then k equal to minus 3 upon 2. Okay. That means k is minus 3 upon 2. That is the zero of this polynomial is minus 3 upon 2. Okay. Now let us draw the graph of this polynomial. For that, we are drawing a table like this. Here, we want to plot some points on the graph paper and we want to get the graph. So we are substituting the value x equal to k here. We are substituting x equal to minus 2 here. Then we are getting, see, y equal to 2 times minus 2, x equal to minus 2 plus 3. Then we will get minus 4 plus 3. That means y equal to minus 4 plus 3 is minus 1. So when x equal to minus 2, we are getting y equal to minus 1. So we are forming this table and we are giving x equal to minus 2. Then we are getting y equal to minus 1. Okay. Then next we substitute the value x equal to 2 here. Then we are getting y equal to 2 times 2 plus 3. That is equal to 4 plus 3. That is equal to 7. That means when x equal to 2, we are getting y equal to 7. So here we are getting 2 points which satisfy this equation y equal to 2x plus 3. Which are the points here? So we are getting 2 points, minus 2 minus 1 and 2 7. So we are plotting this 2 points. So here we are drawing the graph. First you draw the x-axis and then we are drawing the y-axis, then marking the points, then we are plotting the points. Minus 2 minus 1 is here. The next point is 2 7 here. Then we join these 2 points by a line and we are getting a graph as a line. This is a linear polynomial So for linear polynomials, we are getting a line as a graph. Okay, always we get line for linear polynomials. See, you just observe this graph. This line intersects the x-axis at this point. What is the coordinate of this point? And already we have seen that the 0 of this polynomial y equal to 2x plus 3 is minus 3 upon 2. Thus, we can say the 0 of the polynomial 2x plus 3 is the x coordinate of the point where the graph y equal to 2x plus 3 intersects the x-axis. Have you understood? That means the 0 of the polynomial is the x coordinate of the point where this graph intersects the x-axis. Are you following? So, if you are given a polynomial p of x, then what is the 0 of this polynomial? That is the x coordinate of the point where the graph intersects the x-axis. So, that is the geometric meaning of the 0 of this polynomial. Okay, let us generalize this. See, consider the 0 of the polynomial p of x equal to ax plus b. Then k is the 0 of this polynomial. That means p of k equal to 0. That means ak plus b equal to 0. Then ak equal to minus b. Then k, that is the 0 of the polynomial, is negative b upon a. Okay. So, where this graph will intersect the x-axis, that is negative b upon a, 0. Is it? So, you can say, for a linear polynomial ax plus b, a not equal to 0, the graph of y equal to ax plus b is a straight line which intersects the x-axis at one point. What is that point? Negative b upon a, 0. Then you can say the 0 of the polynomial is the x coordinate of this point, and that is negative b upon a. Okay. So, if you are given a polynomial like this, y equal to 7x plus 2, then what is the 0 of this polynomial? That is negative b upon a. This is a and this is b. Okay. That means negative 2 upon 7. That will be the 0 of this polynomial. Have you understood this? Okay. Then let us come to a quadratic polynomial. Consider the quadratic polynomial p of x equal to x square minus 3x minus 4. We want to find out the zeros of this polynomial, and we can draw the graph of this also. So, we are substituting these values. Minus 2, we are getting 6 as the value of this polynomial. If you substitute negative 1 for x, we will get 0 as the value of this polynomial. If you give x equal to 0, you will get negative 4 as the value of this polynomial. And we are substituting these values. X equal to 1, we are getting minus 6. If you put x equal to 2, we get y equal to minus 6. And if you substitute x equal to 5, then we are getting y equal to 6. Okay. Then from this table, we can see what are the zeros of this polynomial. Can you say? See this? Here y equal to 0. That means the value of this polynomial is 0. That means what is the 0? Negative 1 is the 0 of this polynomial. Is it? Then you observe this. Here also y is 0. That means what is the 0 of this polynomial? 4. That means from this table we can see -1 and 4 are the zeros of this polynomial. Okay, so we got the zeros. Then using this table, we can draw a graph like this. First we are drawing x-axis, then y-axis, then marking the points, then we are plotting that points given in the table. Okay, we are plotting these points. See, the points given are -2, -6, -1, 0, and 0, -4, then 1, -6, then 2, -6, then 3, -4, then 4, 0, then 5, 6. We are plotting these points and joining these points using a curve. Then we are getting a graph like this. If you observe this, you can see that this graph intersects the x-axis at these 2 points. Which are these points? -1, 0 and 4, 0. Already we know that -1 and 4 are the zeros of this polynomial. So we are consolidating the idea we got here. See, from the table we can see -1 and 4 are the zeros of this polynomial. From the graph we can see that -1 and 4 are the x coordinates of the points where the graph of this y equal to x square minus 3x minus 4 intersects the x-axis. Okay. So, you can say the zeros of the polynomial are the x coordinates of the points where the graph intersects the x-axis. What are the zeros of a polynomial? That are the x coordinates of the points where the graph intersects the x-axis. Then if you generalize this, see, if any quadratic polynomial ax square plus bx plus c a not equal to 0, then the graph of the corresponding equation y equal to ax square plus bx plus c has one of the two shapes, that is this shape, okay, or this shape, depending on the value of a. If a is greater than 0, then this is the shape. If a is less than 0, this is the shape. These curves are called parabolas. Okay, so we are getting parabolas as graph of this quadratic polynomial. So from our observation about the shape of the graph y equal to ax square plus bx plus c, the following 3 cases can happen. What are they? See the first case, case 1. Here the graph cuts the x-axis at 2 distinct points, a and a dash. Here x coordinates of a and a dash are the 2 zeros of the quadratic polynomial ax square plus bx plus c. See this? Here, this is the graph of ax square plus bx plus c equal. Here the graph cuts 2 points a and a dash. Then the zeros of the polynomial are the x coordinate of this a and a dash. Okay. This is another case, 2 intersecting points. Then zeros of the polynomial are the x coordinate of this point and this point. And this is another case. Here a and a dash are coinciding at this point and this is the intersecting point. Here in this graph, this is the intersecting point. So here we get 2 coincident points and the x coordinates are the zeros of this polynomial. This is the third case, but here this graph is above the x-axis and here it is below the x-axis. this graph is not intersecting with the x-axis, that means there are no zeros or no solution for this polynomial. That means you can see geometrically that a quadratic polynomial can have either two distinct zeros or two equal zeros, that means one zero, or no zero. That means graph is not intersecting. This means a polynomial of degree 2 has at most two zeros. That means two zeros or one zero or no zeros. Understand? That means some cases it has two zeros, some cases it has only one zero, that means coincident. In some cases, no zeros. That is a conclusion about the zeros of a quadratic polynomial. Okay. I think all of you understood this class. Then we can continue the class in the next part of the class. Okay.